Hi there, thank you for showing up here learning again. Yeah, so picking up from where we just left off, this point here that goes around in the circle, it bears mentioning how you create that point. Here, cosine A, sine A. So that's an idea. There's the unit circle there that it's traveling around. Here is the circle. And any point on that circle can be given by the cosine of the angle A and the sine of the angle A. That was an idea that we saw already in this graph in here. So you can access this graph. It's a publicly available one, trigonometry unit circle, open graph. And you see here cosine A sine A, let A play. For some reason, whoever created this didn't think to set that slider to 0 360, so it does something weird. And then the way you change its direction is you say just animate in one direction only. And there, let's let it go. See, as A changes, that's the angle A that's formed between the x-axis and this red arm here, the terminal arm. That point just keeps going around and around and around. That point given by cosine A sine A. Okay, so that's going to connect to some of our ideas with Ferris wheels, and we're going to take a look at Ferris wheels now. So I just wanted to highlight that this idea here is a very cool one. You can use it for your own playing around. Mr. Wiggly Mustache, another one of my graphs that I created. I used that a little bit as well for his weird googly eyes that go around in circles. But those are a little weird. They change a little more. This is again like a phase shifted, just with a D that keeps changing. Okay, that's enough of that, don't you think? All right, boop. Okay, and then good, boop. All right, we'll leave that one open. Okay, so now we're going to carry on with today's sinusoidal word problems. Sorry, it's taking me a long time to get to this lesson. Okay, so here we go. Day 5. Yeah, right. We're day 3, and it's been a bit of a rush, hasn't it? But it's the whirlwind tour. So here we go. Continue the whirlwind. Alexa riding on a Ferris wheel. Her height above the ground in meters is modeled by h of t. Okay, so they have a function h of t, where t is the time in seconds. All right, so you have seconds here, and you have vertical displacement here. That's height. So we can find out from here that she got on at 0 seconds, and she got on at the bottom of the Ferris wheel. All right? Her highest point she reaches after 20 seconds, and no surprise, she reaches the bottom after 40 seconds. It takes just as long to go up as it does to go down. So we already know a lot about not only the Ferris wheel, but also the function that could model this Ferris wheel and that would produce this curve here, this sine or cosine wave. And we're going to see it's actually a little easier to use cosine in this case, and I'll show you why. Okay, so we're going to have a function h of t. Let's create this function. H of t. T is time now. This is the t-axis, not the x-axis. And it's going to be equal to, well, we want to know, first of all, the amplitude. And the amplitude, what I want you to notice here is that the amplitude is from the midline up to the maximum or the minimum, doesn't matter. All right, so we can see that that's 10. Okay, and that tells you that this has a radius 10. This Ferris wheel has radius 10. Okay, that's its radius. Equals the radius. Okay, and so that's the amplitude. And so amplitude is often going to be related to like how big a wheel is, if it's a water wheel turning, if it's a bike tire, if it's a Ferris wheel. It's always going to be the radius of that tire is going to give you the amplitude of that sine wave. The period here, we'd get that from here to here, and that we can clearly see as 40. Okay, so there's the period. Okay, the horizontal axis is over here, and that's at 15. So y equals 15. What is that? Well, that is the height of the axle. The axis is the axle. Okay, so the axle of the Ferris wheel, an axle is a bar that turns and a wheel goes around. Okay, so that's what an axle is. So here, this is the axle here. And it's, where do I draw it? I draw it by moving my face. Why am I so in the way all the time? Here's the ground. And the height of the axle is 15. Okay. And the last thing is the phase shift. The phase shift is where this touches the y-axis and how much has been shifted left or right. That's going to be your d transformation. And here we notice this is our starting point here. So for phase shift, that's important. We want to start at negative 90 degrees or 270 degrees and go up if we were using sine to model our vertical displacement. Okay, we don't have to use sine, and I'll show you why. Okay, let's keep going. So now we know the midline, we know the amplitude, and so those are some important transformations. Let's put them in. The amplitude is related to A, that transformation. So A is 10 meters there. The midline is 15, so C is equal to 15. The phase shift we'll talk about later. The period. Okay, so period here. We want to know that. And so period is equal to, K. K is equal to 360 divided by the period. All right, so 360 divided by 40, K is equal to 9. Okay, so we've got A, we've got C, we've got K. We need to figure out D. D is the trickiest, and is always tricky. Well, it's still tricky for me, but I know what it is. I know how to do this in my head, but it's still tricky. Okay, so now if I'm going to be using sine, what I do is I notice this is the usual starting point for sine. Okay, there's one method, is to use the graph and to say usually sine would start there, but I want this to be pushed that way by how many units? 10 units. Okay, so if I subtract 10 from all my inputs, it's going to do that. It's going to move over. The reason is that's 10 units there, and it's going to go poof, over by 10 because D is a sign flipper. Okay, so when I'm writing this in, I'm going to have h of t. Well, it's going to be some a multiplied by sine bracket k times x minus d and bracket plus c. We already know a. Okay, this is our general untransformed one. Now let's produce our transformed one. Okay, we're going to have this is equal to 10 times sine. K is 9. Do you see where we got that? We use this formula for k is equal to 360 divided by the period. All right, multiplied by x minus 10, because we move 10 in the positive direction and it's a sign flipper, so make sure that's minus 10, plus the value of the horizontal axis, so that's plus 15. This, when we check that in Desmos, is going to give us the function that we're looking for, and I'll prove it to you. And voila. Okay, so here you see we get on the Ferris wheel at the bottom. We rise to the highest point at 20, and we go to the bottom point at 40. So that works. All right, that worked. All right, so the minus 10 worked. Now, maybe you're sitting at home saying, okay, Mr. Jennings, you've shown us one method for finding this D, okay? You said you knew that sine's phase shift was usually starting there, and you wanted to pull it that way by 10 units. I wouldn't be able to do that. Maybe you couldn't do that. I don't know. So here's another way you can do it. Okay, you can use the Fiddle method in Desmos. This is a good method for learning. Okay, you couldn't do this on a test, but you could do this to Fiddle. Okay, if I put in a slider D, add the slider, and then I want to look at like, well, D is 0. So this would be an unmoved sine wave. So you see there, it's crossing right at the horizontal axis, like I told you it would. So not an asymptote. And then as I change this slider D, oh, that's more like what I want. That's more like what I want. That's more like what I want. That's exactly what I want. Okay, so you can use a slider to find it too. Okay, and you're gonna learn this stuff by seeing it move around. So that's one way. Okay, another way that you could do it is you could look at this and say, that's the bottom. I'm getting on at the bottom. So I want this to start at sine is equal to 270. Okay, and then you would look at, well, I want, why 270, Mr. Jennings? Well, this would be 0 degrees. That's where sine usually starts, at the midline. And then it goes up. And then it comes down. And then it hits this point.
Dad, are we going to have a movie today?
No, it's not movie day today, Miles. So then we're going to hit this. Then we're going to hit this point at 270 degrees.
It's birthday, Dad.
You're right, mister. Okay, so so this was 270 degrees. But Mr. Jennings, I don't see anything to do with 270 there. Okay, so let me show you how you would use that idea. Okay, so, and you could also use negative 90 because negative 90 is the same as 270. We're going to see we get a different answer here that's the same. So you'd take this mini equation, okay? You would say, I want that to be 270 is equal to this stuff when x is 0, okay? Why 0? Because this is the y-intercept, okay? So you're going to have 270 is equal to 9 because we know k has to be 9 because its period is 40. So 9 times 0 plus d. 9 times d. Okay? So 270 equals 9 times d. Divide both sides by 9 will give you 30 equals d. And that's positive 30. Okay? So we could have also said this is equal to 10 sine 9 times x plus 30. Notice that those two are different by 40. Notice they're different by the period, okay? We're actually grabbing a different point and pulling it so that this function will still work. Watch. I'm going to go in here to here. I'm going to take my slider D and I'm going to make that 40. Okay? So here, if I click away, see it works at 10, but if I make this play, if I grab this here, it works at 10. It gives me what I want at 10, but it will also give me what I want at plus 40. Plus 30. What am I doing? Plus 30. Just type it in, Mr. Jennings. See, it also works at D is equal to 30. Okay. It also works when I have D is equal to positive 30. Okay. So those are two different ways to get your phase shift. Okay. Now let's carry on because I think people are kind of bored of this problem. So I think you should go ahead and create your own Ferris wheel problem. Now, I created my own Ferris wheel problem when I was doing this with the other class. So I'll link that video. Oh, that's not in the video. So what you could do here, if you want to create your own Ferris wheel, this is super fun. You can imagine your own Ferris wheel, or you can find a Ferris wheel in the world and model it, pair some pictures with it, share that with the class in an interesting way. That could be your assignment this week. Okay. I'm not going to do that one, but I will talk about this one because I've created my own Ferris wheel. Here it is. It's a word problem that we'll do together. There was a new Ferris wheel at Ripley's Aquarium. It goes 30 meters into the air. That's its highest point. And its lowest point is 10 meters underwater. There's actually 2 shark tanks that it goes between and then comes back around. Don't worry. So there, you go between the glass panes. You're not going to get eaten at the bottom of the Ferris wheel. Although that would be a very interesting way to feed sharks. You board the wheel at the water line and you go up. Okay? And the Ferris wheel makes 1 revolution every 3 minutes. So we want to know, how long are you underwater in that shark tank? Maybe you want to take lots of pictures and you're wondering how much time you're going to have. Or you're going to take a video, but you only have, 1 minute of time on your phone to take a video. Can you take the video? First thing I would do here is draw a diagram. So let's actually go ahead and we'll diagram it up here. So here's our Ferris wheel. And it's actually not very convenient to diagram it on this one. Well, actually, it's not that bad. So if we go down here by 10 and we go up by 30, so this would, if we use 10 as our scale here, this would be 30 meters in the air, and that would be the highest point of our Ferris wheel. And then that would be the midpoint there because I have already done the mental math in my head. So that is a circle. And its bottom point is down there, 10 meters down there. And then it comes up. Wow. Wow-a-wee-wa. Okay, so I'm cursed with having this like vivid visual imagination and terrible artistic skills. So I do thank you for your patience with me. So here I have drawn on our Ferris wheel. We get on at the water line, which is right at 0. That's our 0 line. It's not our horizontal axis though. The horizontal axis is going to be the axle there, which is 10 meters off the ground. The highest point is at 30 and the lowest point is at minus 10. The shark tank is down here with scary sharks in it. And you get on there and go around, and it takes 3 minutes. So I've changed the scale here. These are not degrees, they're now seconds. Okay, so these are seconds along here. So we know that we'll be here at 0, and we'll be here at 180, okay, because that way we'll be back at our starting position. We're going to go up, come down, and go up again. But we don't know any other points by just looking at it. So let's figure it out. And we'll figure out a trigonometric function that's going to model us going up, reaching our maximum, come down, reach the minimum, and then come back up again. And then we want to know how long we're in the shark tank. So we just want to know how long is this interval here. All right, so let's take a look at it. And actually, let's just do it. So let's write down what we know. We want to know about our amplitude, and that's going to give us A. Well, that's the height of the axle. Because it's 40 across, the axle, the radius would be, so not the axle, the radius of this Ferris wheel would be 20. So the A is going to be 20. The distance from the midline to the highest point is 20. The midline to the lowest point is 20. Another way of thinking about it. C is the horizontal axis, and that's over here at 10. All right, it's 10 high. So C is 10. K is going to be equal to 360 divided by the period, which is 3 minutes, but we're measuring in seconds. So 180. Well, that was easy. K is equal to 2. All right. Last thing is the phase shift. And there's a few ways to do it, of course. There is, I am starting down here at a negative 30 degree angle. Sorry. Just looking at the unit circle, that's definitely that, because it's 1/2 the way down. So the value here would be sine is like negative 1/2. That's negative 30 degrees. Now that's me being a smartass. Okay, so let's figure it out if you're not sure. Okay, so the one way to do it is to plug and chug and solve with algebra. Okay, let's take a look at it. We're going to call this h of t. This is height as modeled by time, and it's equal to a is 20 multiplied by sine of, we have it's sine bracket 2 multiplied by x minus, I don't know d yet. I do, but you don't. Okay, and then also plus 10. Okay, I know that h at 0 seconds is also 0. Why do I know that? Because you get on at 0 and then you go up. Okay, so here's another factoid that I know. That's very loud, isn't it? I know that h at 0 is equal to 0, so solve. Okay, put in your 0 here. This is h at t is equal to 0, is equal to 20 multiplied by sine 2 times 0 minus d plus, why did I put plus 0 here? That's so strange, Mr. Jennings. It's plus 10. The horizontal axis is 10. The c is 10. It's right there. It's so strange that I wrote that. Plus 10. Okay. Now rearrange and solve. Move the 10 over there. So I have negative 10 is equal to 20 sine 2 times 0 times negative d. So this is negative 2d. Okay. Just 0 minus d is negative d. 2 times negative d is negative 2d. Okay, there you go. And that's now on that side. Divide both sides by 20. Gives me negative 1/2. Oh, there it is. I told you already. It's negative 30 degrees. Negative 1/2 is equal to sine of negative 2d. All we did there was, I'll just show your inverse operations, Mr. Jennings. You might as well show them. Minus 10. Minus 10 to both sides. Divide both sides by 20. Okay, and then that's how you get this line. All right, now you have something that you can now solve for this. The way you're going to do that is going to look like this here. You're going to inverse operate the whole thing. You're going to go sine inverse of negative 1 over 2 is equal to negative 2d. Okay, so that's your line. You've taken the inverse sign of both sides. It effectively took this sign away and put inverse sign on that side. That's your inverse operation. Now, you solve that on your calculator. You say, what angle is going to give me a sine of negative 1 over 2? And you can consult your unit circle and you can find that. Or you can punch it on a calculator. And I am going to risk my ugly calculator to do that for you. Oh, how much I wish I could use my handheld. So I'm going to go 1 divided by 2 equals 0.5. I want the negative of that. Okay, and then I'm going to say second function, sine inverse of negative 1/2 tells me negative 30, like I've been saying over and over again. That's how you punch it on your calculator. So yeah, take that, negative 30. So now what I know, oh, hold on one moment. Yes, Miles?
Can you fix this?
Negative 30 equals negative 2d. And give me one moment, everyone. Crisis averted. So now I have this, right? This, my calculator tells me the angle that produces a sine of negative 1 over 2 is negative 30. It could have also said 330, but who cares? Okay, negative 30 works wonderfully because when I divide both sides by negative 2, I get 15 equals d. Okay, that's telling me that the function that I want here is right here, but I just need to take 15 is equal to d and sub it in there for d. Remember, this is a sign flipper. You've got to have negative d. So I now know that h of t is equal to 20 sine 2 times x minus 15 plus 10. Graph it in decimals. Looks pretty good, eh? So we get on at 0. We go up. We reach our maximum here at what time? Exactly 1 minute. Isn't that interesting? And then we come down and we enter the shark tank at 120 seconds. And then we go down and we are at the bottom at 150 seconds. And then we come up at 180 seconds. So how long are we in the shark tank? Exactly 1 minute. Wow. So if you had 1 minute of storage space on your phone, you could take this video of the entire trip through the shark tank. And then, when will the next time you visit the shark tank be? Well, if you kept on going around, you would go back up to the top of the Ferris wheel and come down. I predict, without looking at the number, that if I just took the period, okay, the period is 180, and I added the period to this first time I submerge, that will give me 300. And then the next one should be 480. Yeah, 300. Let's see, is it 480? It is. And then let's see, what's the next one? What's 480 plus 180? Okay, what am I doing here? I'm finding the infinite number of times that you would go down into the shark tank. And the next one will be over here at 660 because that's 480 plus 180. Okay, and then so on and so on and so on. So that's the idea of using the repeating period to find all the times you're underwater. Okay, so yeah, you spend a full third of your time on this ride underwater. Isn't that cool? Super cool. Okay, now let's take a look at more problems. So that answers that one. Okay, you missed one revolution every 3 minutes. How long are you in the shark tank? Well, 1 minute per revolution is our answer. Okay, now next one. Mr. Jennings, disguised as homework man, despised by all students. He is swinging back and forth on a rope. I actually got this question from another teacher. I changed it to my name though because I did make some changes. And he's swinging on a rope for some reason back in front of the math class window for some reason. And at time is equal to 3 seconds. I'm at one end of my swing, 4 meters away from the window. At time is equal to 7 seconds. I'm at the other end of the swing, but I'm 20 meters from the window. I must be swinging from a very long rope or swinging very, very high. Wow. Okay. If you wanted to throw a chalk eraser out the window and hit homework man, find 3 different times where you could do it. Okay, let's see if we can use our knowledge of trigonometric functions to do that, to figure out when to peg me with the chalk eraser. So we know these things. T is equal to, so we know that there's some like distance from, wait, we should draw a picture first of all this because I think some people don't know what I'm imagining. And so that you're clear on what you're imagining, you should draw a window, okay? And there is someone swinging here. We know that at the top of one swing, I am 4 meters from the window. And let's just, this 4 meters horizontally, okay? So up here, okay? and that's 4 meters from the window. And that's the top of one swing. And then I swing past the window. I go all the way over here. And that's there 20 meters from the window. I'm swinging over here. The swinging point must actually be in the middle over here somewhere. Okay, so I'm not going to pause and do a better picture for you. I'm just gonna leave it at that. So that's 4 meters away from the window. That's 20 meters away from the window. I'm there at 3 seconds, and I'm here at 7 seconds. So I'm actually swinging super fast. Like, what's going on? And what's the gravity in this place anyway? Super strange. I don't know that this is possible, but they're not my numbers. They're someone else's. Okay, so that's what's going on here. And let's see if we can model this. So we're going to have some distance from the window, and it's a function of time. And you want to know when that's 0. Because when the distance from the window is 0, I'm right at the window, and you can peg me with the chalk eraser. So let's go for it. We know that d of t is going to be some a times sine multiplied by some k multiplied by, oh, this is t, not x, because we're talking time, minus some horizontal displacement d, some phase shift. So who knows even where I start yet? It's actually pretty challenging, this problem. D is t, then plus c. Okay, so let's take a look at what all these mean. A is going to be the amplitude. Here I'm 4 meters away. There I'm 20 meters away. So the total distance, and we're going to call this negative distance and this positive distance. Otherwise, it gets really kooky. Okay, so the total spread in distances is 12. So I know that the amplitude is going to, the total spread in distances is 24. So the distance, the average, like the distance from the midline is 12. Okay, now you would get that from like the formula A is equal to like D1, like maximum plus minimum divided by 2. And there it's a negative 4, negative 20. So, no, wait, minus. So anyway, what am I talking about? It's just go straight forward, Mr. Jennings. So this is 12. A is 12. Let's talk about C. Well, the middle position here between negative 4 and positive 20, well, negative 4 plus 20 would be 16. So the average in the middle is 8. My middle position here is 8 meters from the window this way. And you'll notice that cuts it in half. There's 12 on this side and 12 on that side, 8 plus 4. So C is equal to 8. All right. I feel like I'm losing some of you, so let me draw a better picture, and I am going to pause, and we're going to do a better picture somewhere. All right, everyone, so I got a great picture for you now. So here's the window. If I'm 4 meters away at the top of one swing and 20 meters away that way, the total distance is here 20. The window is 0 and negative 4, so the total distance is 24. Okay, that tells me that the midpoint is there at 8. All right, and that's 12 from the max and 12 from the minimum. So the amplitude here is 12, and the midline, the horizontal axis, is 8. All right, and then I know that I'm here at 4 seconds and there at 7 seconds. So I will come back every 6 seconds because it takes me 3 seconds to go from one end to the other, and then 3 seconds, presumably, to come back. So a total period of there and back again will be 6. So let's go back up here. So I know A is 12, C is 8, K is equal to 360 divided by the period, which is 6. Okay. I'm wrong. Yeah, so t is equal to 3 seconds and 7 seconds. So actually, it takes me 4 seconds to get all the way there and back again. Sorry, I had the numbers backwards. Did I write that down wrong? No, I did. Yeah. So this is not 4 seconds. This is 3 seconds. Okay, so now the period is 8. Okay, this is 8 is the period. I'm sorry. I hope everyone's still following me. That's why I need an 8 there, because I made a little mistake. It takes me 4 seconds to go, 4 seconds to come back. Total period, 8. So let's figure out what our K is. 360 divided by 8 doesn't go evenly. It does go evenly. It is 320 would be 40, and then you add another 40, so it's 25. 25, right? Check your work, Mr. Jennings. 25 times 8 equals 30, 45. Sorry, 45. 45 times 8 equals, there we go, 360. Yeah, 45. So K is 45. Okay, and now we need to figure out the phase shift. That's always the trickiest part. So what I'm going to do is solve. All right, and I'm going to use this point here to solve 3 seconds. Did I write that down correctly? Yes, I did write it down correctly here. Okay, I think I got the 4 over there. Wrong spot last time. So what I'm going to do is write down d of t, distance as a function of time, is equal to a, which is 12, sine of bracket 45 multiplied by x minus d, and bracket plus c, which is 8. Okay, and I know that at 3 seconds I'm at -4. Okay, and I wrote x there. It's not x, it's t. It's t because it's time. Okay, so we're going to use t as our variable. You could use x, but you should have x there as well. Okay, so I know that d at 3 is equal to -4. Okay, because I'm -4 meters from the window. We identified that direction as negative movement, and that direction is, that direction is negative movement, that direction is positive movement. Okay, so -4. So it subs that in. -4 is equal to 12 times sine of 45 times -4 minus d. Okay, plus 8. Okay, so now I'm going to simplify. So my first inverse operation is I'm going to add a -8. I'm going to subtract 8 from both sides, and then divide the rest by 12. Okay, so I'm going to get -1 is equal to sine 45 times -4. I'm going to figure out how to use the editor and edit this part out because I've made so many errors. Or do I leave them in and model a growth mindset? Okay, I'll try and use the editor, but I may leave that mistake in. If you're watching, you'll know if I left it in or not. D at 3. Okay, this is 3 seconds, so 3 substitutes in here for t. I'm just flipping my 3s and 4s here throughout this problem, and it's highly annoying to you and to me, I'm sure. So I substitute in 3 for t. Okay, because d at t is 3. Okay, and that's equal to -4. All right, so now we're going to do our inverse operations, and the first few are the same. So I'll do them in 2 lines this time because I was regretting trying to do it in 1. Subtract 8 from both sides gives us, this is now -12 is equal to 12 sine 45 times 3 minus d. Okay, and now I can divide both sides by 12 to give -1 is equal to sine of 45 times 3 is 135 minus 45d. Okay, so that's just doing the Bedmas inside there. All right, now I can take the inverse sine of both sides. And I want to say, like, what gives me a sine of -1? Well, sine of -1 happens at 270. So this is 270 is equal to this. Do you believe me? Maybe you don't. Okay, let's take a look at y. Okay, so y is that? Well, if I look at my unit circle, the value of sine that is -1 is 270. Or the way I would do that is I would say, well, I have this number and it's -1, and I want to know what gives me that sign. And it's negative 90. It's not 270. It's negative 90. I must have made a mistake. No, of course, that's the same thing. This is negative 90 degrees. Okay, negative 90 is 270. So yeah. So when I take the inverse sine of both sides, just having trouble finding it. There it is. I find that 270 equals this. 135 minus 45d. Subtract 135 from both sides. This is double 135, so I have 135 is equal to negative 45d. $135 equals negative 45d. Okay, now divide, because that's just, if you want to see it, it looks like this. Subtract 135 from both sides. Okay, so then I get that. Now divide both sides by negative 45. Don't these numbers work out beautifully? Whoever created this question is a genius. It was not me. These are not my numbers. They work out very nicely. So now I just evaluate that and I found D. So 135 over 45 is 3. Negative 3 is equal to D. All right, there you go. So I had negative D there, so I'm going to actually have 3 t plus 3D. So let's go up. We'll find our initial function here. Here was the function. All right, and we're going to want to find, okay, so we're going to say D is a function, distance from the window is a function of time, and it's equal to 12, because that's how much I'm swinging in both directions. Why am I doing this? Times sine of 45 multiplied by t minus 3, but this is minus d, so it flips signs. T plus 3 plus 8. Let's graph that in Desmos. Oh my gosh, Mr. Jennings, I got this. Yeah, it's because your scale is way off. So when I'm setting my scale, I know that like time is along this x-axis here, and we were looking at values of time that were like 7 seconds, 3 seconds. So we're looking at smaller numbers. So put in smaller numbers here. Let's put in 34, because I'm a maniac for Fibonacci numbers. And we'll look at 0 there, because again, Fibonacci numbers. And there we go. This is the function that models my position as I do this. So at time is equal to 3 seconds, I'm at my furthest point from the window, which is minus 4. And then at t equals 7 seconds, I'm at the furthest position opposite that, which is 20. Let's see, where do I cross? Okay, at 1.9 seconds, you could hit me with a chalk eraser, but you probably don't know I'm coming yet, because I just left one side of my swing there. And then here, 4 seconds is another time you could hit me with a chalk eraser. 9.9 seconds. And then 12.07 seconds you could hit me with a chalk eraser. So you have lots of opportunities, okay, is what I'm saying. You got lots of opportunities to smack me through the window. Now, you're saying at home, okay, that's fine and good, Mr. Jennings. You can solve it with Desmos. How do we solve it with our calculators? So let me show you what you can do algebraically. So you have your function, all right? And you say, I want to know when that's equal to 0. So what values t give me a 0? And so you go here, you say 0 equals 12 times sine 45 multiplied by t plus 3 bracket plus 8. And then just solve it, okay? Move the 8 over, negative 8 is equal to 12, sine all that stuff. You might skip a step here and just divide to avoid having to write the whole equation again. But notice that I do, okay? I notice some of you don't, and then you make mistakes, like you will skip writing that down or something. Write down things that are true. Don't write down things that aren't true. So you got negative 8 over 12. So this is this reduces to 2 over 3, negative 2 over 3. is equal to sine 45t plus 135. Just going to bedmiss that. That's as far as we can go without taking the inverse sine of both sides. So now we have a sine inverse of negative 2 over 3 is equal to 45t plus 135. So this is saying we're going to find some angle here. We're going to find some angle that produces a sine of negative 2 over 3. You'll notice there are no exact values for sine that will do that, but we can find something that will. There's going to be some angle that needs to equal 45 multiplied by the time plus 135. All right, so now we go to our calculator, and we're going to type 2 divided by 3 equals, so that's 2 divided by 3. We're going to make that negative, and then we're going to say take the inverse sine of that. And then what did we get? Negative 42 degrees. We're going to round to 42 degrees. Cool. Okay. I think the person who made this really loves these numbers. There's so many Fibonacci numbers, and 42 is a special number because it's my age. Of course, they didn't know that I would be this old when I did this problem, but they also know that 42 is the answer to life, the universe, and everything from The Hitchhiker's Guide to the Galaxy. So now we have this equation here, but we know that this is negative 42. So let's just come up here. Negative 42, right? Not 42? Negative 42? Yes, negative 42. This calculator likes spitting out negative angles for some reason. So negative 42 degrees is equal to 45 t plus 135. Subtract 135 from both sides. Oh, and here we can do something else. We want to look at this negative 42 degrees, and we want to find other things that have the same sign as that. So let's take a look at it. Here is negative 42 degrees. Okay? And what has the same sign as that? This angle over here. Okay? Will also qualify. And that's going to be the two solutions that we have. Where are those two showing up in the function? Well, they're showing up there and there. Okay, you need both if you want to have as many opportunities as possible to peg me with a chalk eraser. Everyone wants more of that, right? So one of the casualties of distance learning is you can't peg me with chalk erasers. So this was minus 42 degrees, otherwise known as 360 minus 42, which would be, sorry, what is that? That's 320, no, 318. 318 degrees, or this is negative 42. That's now 42 degrees. This is 180 plus 42. So 318 degrees is one solution. I'm going to work with that number. Or 180 plus 42. So that would be 222 degrees. Such cool numbers that they created here. So we get too many equations, actually. I'm not going to use this equation. Too many equations to solve. We have 318 is equal to 45t plus 135. That's going to give us solutions number 1. And solutions number 2 are going to come from 222 is equal to 45t plus 135. Okay, so now let's do our inverse operations. We're going to subtract 135 from both sides. We're going to subtract 135 from both sides in both equations. Okay, and then we're going to get two new equations. This is 318 minus 135, which is, did you know I woke up at 4 today to teach you guys? Okay, this is 218 minus 35, which is 183. 183 equals 45t, he thinks. And then 222 minus 135 My children like to take my calculator and run off with it, so I'm going to use the calculator on my phone if you don't mind. And my brain is tired, okay? So I'm not going to do this in my head. Maybe your brain is tired too, and you're doing things on your calculator that you should do in your head as well. And I forgive you. We all need to be understanding of one another during distance learning. 2 minus 135 equal, well, of course, that's 87. And so that's 87 equals 45t. And here, just checking my work. 318 minus 135 is 183. I got that one right. Oh my goodness, I'm kind of shocked. Now I'm going to divide both sides by 45. Forgive me for not using a different color. And that's going to solve for t. So t equals what I'm going to punch on my calculator here as divide by, not clear, 183 divided by 45, 4.0006. T is equal to 4.0666666666. So, or 67. So we're going to round that. We're going to circle it. That's one of our solutions. And then this one gives us the other one. 87, clear. 87 divided by 45 is a little bit less than 2. So that's T is equal to 1.93 repeating. So that's 1.933. Okay, there's my other solution. So now you got 2 options of when to peg me, but I asked for 3. Okay, and let's just go check in Desmos. I'm a little bit scared actually to check this in Desmos because I'm not sure if I got this right or not. Let's go check. Oh, thank goodness. That's my 1.93. So you see 1.929 is really close. And then this one, 4.07. We got it right. Yes. Definitely give yourself a pat on the back. 4.07. Okay, so it's 4.067. This is very close. Very close. We rounded, but we're still very, very close. You're still going to hit me with a chalk eraser, okay? Because I'm big enough that you have some margin for error. I'm bigger after the holidays. Lots of chocolate in my stocking. Santa was very generous with the candies. Okay, so now I've got 2 solutions. How do I find more solutions? Just take the period. Okay, we know that the period is 8 seconds. It takes me 8 seconds to go back and forth. So add 8 to that, and you'll get 12. Add 8 to that, and you'll get 10. Okay, let's see if we get those 2 from Desmos. There's 10. There's 12. And then there's going to be another one at 20 and 18. Okay, so those are all the possible times you can peg me with a chalk eraser. I think that's enough practice problems, don't you? I think I should probably do some parenting, don't you? Yes, I think so. So that's our lessons for today. All right, everybody. We went from some challenging questions to some very challenging questions. There's another one here. Sam is riding home from school one day and picks up a nail in his car tire. The nail makes a grating sound whenever it's in the wheel well 30 centimeters off the ground. It's a very similar question to the Ferris wheel question. We answered that one exhaustively. So I'm not going to do it. I'm going to say that's enough. I have done enough practice. If you want to see more, ask me in the meet, okay? Come to the meet and say, show me another question, Mr. Jennings, and I'll be really happy. It actually makes me really happy to talk about these things because I really enjoy this topic. It's my favorite topic of the whole course. This is my favorite course. I'm not teaching this course next semester. So definitely come to the meet and talk to me about this stuff. And I will love to chat about these things. Maybe you can come into the meet and then leave the meet and then come into the meet and leave the meet and then ask me to solve for how you're periodically appearing and disappearing. And I'll be tickled. Okay, so bye for now, everyone, and definitely enjoy your practice today as much as I have, and you will be loving your math. Bye for now.